nanoHUB.org.
Online simulation and more for nanotechnology.
Hi everyone, I'm gonna get started. So thanks everyone for joining me for the first session of the hands-on data science and machine learning training. In this session, we're gonna start with an introduction to Jupyter Notebooks. Then I'm gonna introduce a couple of libraries so you can do data organization and plotting. But before we get into that, let's start with some motivation. So as in commerce, marketing, and finance, data science and machine learning are playing an increasingly important role in science and engineering. The goal of data science is learning from existing data to create predictive models for regression and classification. It can also be used as techniques for dimensionality reduction. And moreover, it can also serve to inform the design of experiments to facilitate generation of new knowledge. Data, as you can imagine, is the key ingredient to make all of this happen. Thus, several infrastructure platforms have evolved to offer repositories and tools to mine them. In this session, we will use nanoHUB, which is a resource for researchers to run cloud computing and simulations, and we'll use a couple of their tools for this workshop. So as an outline for this tutorial, we're gonna go through a Jupyter Notebook, already deployed Jupyter Notebook, and we're gonna see how to organize and visualize data. And then at the end, I'm gonna show you ways you can create your own Jupyter Notebooks. So without further ado, let's start this workshop. And please use the subsequent slides. You can see them in the handouts that were handed to you to follow along in this tutorial. So I'll need everyone to visit this link so we can get started. Okay, so you're gonna start by logging into nanoHUB if you have not logged in, and you need an account. So if you don't have one, please create one and then follow along from your handout. So we're gonna start with this tool. We created this tool as a resource for undergraduate material science students. So all of the data is gonna have that theme, but these techniques are applicable to any kind of research being conducted. So once it loads, we're gonna visit the first Jupyter Notebook. So I'll need everyone to just click the first link and it will launch another notebook. Okay, now that we're in this notebook, some of you might be wondering what are Jupyter Notebooks and how are they useful? So Jupyter Notebooks are tools that allow us to create these kinds of documents with instructions and live code for analysis and visualization. These notebooks are being adopted by the community as supporting information for papers, for example, and documents for reproducibility. Jupyter Notebooks are created by using two kinds of cells, mainly by using two kinds of cells, markdowns, which are these text instruction kind of cells, and live code. Here we're using Python 3, so it's the live code that runs in your browser, in your web browser, without you needing to install anything else. So we're going to be working with this already deployed Jupyter Notebook, and then I'm going to show you how to do your own. So for this workshop, you are not expected to be an expert at Python, and not even like an introductory level Python, but you should know some things. So I'm going to walk you through an exercise of like 2 minutes on what you need to know about Python to understand what's happening in this notebook. So Jupyter Notebooks are pretty intuitive to create. The only things that you need to create are these cells, and you can create one from this button here. And you get one of these cells. So as in any introductory coding class, you can print your hello worlds, print hello world. And you can run a cell in a Jupyter Notebook using Shift-Enter. You can see that it prints the string that we have there. So another thing that you need to know is how to create variables. So variable equals something. How to work with the easiest for loop that you can think of. So for something in, let's say this, we can print something. Remember that you can run it with Shift Enter. And that's basically all you need to know of introductory Python to work with this notebook. Okay, we can move on. We created this cell using this plus sign, and we can delete that cell using these scissors. So before we start going through the notebook, I'm gonna explain what the notebook is. So in this notebook, we're gonna start by querying some information from the internet. This is gonna be materials properties. Then we're gonna organize it in dictionaries, lists, and then pandas data frames, and then we're gonna plot it in two ways, using Plotly in two ways. So let's get started. We're gonna start by importing libraries. So libraries are pieces of code published in the internet that help us create functions, that help us to use functions without creating them ourselves. We're gonna use PyMagen and Mendeley. These are both popular libraries in which you can in which you can query materials properties. And we're gonna use them to query properties for these elements. We're also importing pandas, another library that we're gonna use after. So in this cell, you have the imports, and we have this list. This is a list of elements. You can see they're separated by commas. So list. You can run it. Remember, Shift Enter. This is all in your handout. So if you are just joining, please visit the link in your slide number 4, and then just go along the steps. You can see that in Jupyter Notebooks, once you run a cell, a number appears here. This number indicates the order in which the cells were run. So you don't have to run them in order from top to bottom. You can run them in any order, but you want to keep track of when you run in case you need one cell to run before the other one. This notebook is organized from top to bottom because it's easier for users to understand what's happening if it's top to bottom, but you don't have to do it like that. So once we imported these libraries and created this list, we're gonna create another couple of lists. In this list, we're gonna just put all of the properties that we wanna query. And here we're gonna do a mini sample of the big element list. In this for loop, we're gonna be querying for the properties. So making queries is really important when you're trying to get some data from the internet, but we're not gonna delve into the details here. For now, just imagine that for a query, you need one of the elements, so one of the elements dot and the property. If you want to learn how to make more queries or queries to different libraries and repositories, I would recommend attending part 2 of this workshop, in which Zachary McClure will explain how to query some other resources. For now, we're not gonna dwell into the details, so just some element dot the property that we want. So if we run this cell, we're gonna print for these elements the Young's modulus. So we can run it, Shift Enter. And you can see that we're printing the element and the value that we wanted. So you can see that querying using Jupyter Notebooks, remember that this was all already just from a web browser. You didn't have to install anything. It's pretty easy, and you can get the values that you want. Now, imagine that we have all of these properties and all of the elements that we had before. How do we organize them? So organizing data, it's also really important in Python. You have to keep track of what you're doing with your data. So I'm going to show you 3 ways in which you can process and organize your data. The first one is a dictionary. So in a dictionary, you have key and value pairs. So for each key, which is usually a string like this, is usually just like text, you are assigning a value. Remember, something dot a property, this is the value of the atomic number of iron. in this case. And you can store everything in a dictionary, and it's going to get stored in key value pairs. So if you wanted to print the entirety of that dictionary, you could. But if you wanted to get this property specific key from that dictionary, you can query it like this. You can do dictionary and then the property, and you're gonna get this value. So go ahead and run that. You can see that this is the entire dictionary. So this is all the information that we stored from Aaron, these 4 values, and you can see how they're arranged in these key pairs. So for key atomic number, the value is 26. And if we query it like this with a specific property, we just get the value. So that's useful when we're dealing with constants, for example, or if we wanted to deal with things that we know are manageable for humans to just label each of the things that we want. But it's not useful when you have a large data set and you want to keep track on what to do. So for that, lists, just pure lists like the ones we saw before, are useful. Then they are used in Python for that matter. So here we're creating lists. Remember, lists are delimited by brackets, and they are elements with commas in the middle. And we're gonna, instead of just assigning each, we're gonna go ahead and use this method, append. And what this method does is it gets the value. Remember, something.property. It gets the value and it keeps adding it to the list. So in this loop, what we're doing is we're creating the value and then pushing it to the list. And we're gonna end up with a list that is ordered by the element. So this is iterating by an element, so it's gonna go through sample, but imagine it would go like query for this. So the elements in the list will be, the first element of the list would be for this element, and then this element, and then this element. That's a characteristic of lists. So lists are indexed by the way they are arranged. So if you wanted to query, you can also print this list by just uncommenting this. So comments start with the hash sign. So before we run this, let's uncomment these Young's modulus. And if you run it, you can see that you have a list with the Young's modulus of all of the elements. This for loop is running on the big list that we saw before in the first cell. So you can see that for gases, for example, there are no Young's modulus. That's for the material scientists in the audience. So we have to clean this data set still. But you can see that it queried the Young's modulus for all of the elements. So those are lists. Now we can also try to organize. So you can see that this is maybe 50 different values. And if we don't have, like right now that we don't have the map of element to property, it's difficult to keep track of what you're doing. So lists are easy to work with, but they still need some, we can do better. So just going through the code, I'm gonna separate the elements that I want. So I'm gonna get rid of all the gases and all of the elements that do not fit this characteristic here. This is just me reducing the number of elements from the beginning. So we already ran that. And then we can work with lists of lists. So we're gonna create an inner list in this for loop, and we're gonna feed it with this for loop. So here we're still doing the same thing, element dot something here, using the append method to fill up this inner list. And then we're using the append method again to pass this list to the other list to generate a list of lists, which is it's called all values. So once we run this out, we're gonna get into data frames. But just for now, just understand that all values is a list, and each element in all values it's also a list. So for the element, we're gonna get all of the properties in one list, and then just gonna pass that to the bigger list. Now to get into pandas. Pandas is a Python library that offers a set of tools to do data analysis. And with Pandas, you can get most of the functionality of Excel for which you can load, manipulate, and analyze data. This all revolves into these structures called data frames, and we're going to show one of them right now. So the way to create a data frame, there are several ways, but the way we're doing it here is with a list of lists that we created here. Remember, all values. And we can put headers into the columns. So let's just run it so you can see it. This is a way you can organize your data more efficiently. Here we're labeling the properties. So we know what the properties are, and we know which is the order that we put them in. So we can arrange them in these grids. And you can see that for each of the elements, we can have the values for the properties arranged in a way that it's easy to visualize and easy to work with. Here, this data frame, it's called df, and we use the method display to show this. Okay, moving on. So Pandas allows for easier manipulation of the data. One key thing that we can do in just simple code is reindexing. Reindexing means changing these numbers, which are just random assignment of numbers of the entries, to the elements they're supposed to represent. So if we assign from the data frame the index of the elements, here we're using this first list, FCC elements. So if we modify the index of the data frame and we display it again, you can see that it's now the properties and the elements that they represent. So this is an easy example. It's just 12 entries, but Pandas is optimized to work with really big data sets. So moving on, I'm gonna go to binary filters. So in Pandas, you can create binary filters. These are filters that only show the elements when they satisfy a certain condition. In your handouts, you have a list of some standard operations. You also have it here in this tool. So you can do greater or equal, less or equal, equal or not equal. Those are the simplest binary filters you can create. So let's do some of those. So we're going to create another data frame, a filter data frame, with the main data frame for which this property, the first property, it's greater or equal than 150. So you can see that this is just one line, and then we can display this new data frame. So we can run that. And you can see that this is a filtered version of the original data frame, but with this property, with the elements with this property greater than 150 being kept. We can do something similar using equal for the second property from the original data frame, and we can get that filtered. So this example is small, but imagine you have big data. We can also create our custom conditions. So if you wanted, for example, from the main data frame, I want this property to be less than 120, and the second property, this ratio, being greater than 0.25. And that filter will also yield the correct elements that satisfy the condition. So Pandas has a lot of extra features that you can try. For example, it can read documents from Excel. You can upload an Excel and it will show up in Pandas so you can work with it. You can also sort, you can also plot from Pandas, but this is just an introduction. So hopefully this was enough for you to get interested in what Pandas is doing right now. With that, I'm gonna move on to plotting. We're gonna plot using Plotly. Plotly is a plotting library that focuses on creating plots that are interactive, but they keep a publication quality, bringing to the table some features that would be impossible to do with other plotting libraries. So first, we're gonna start with importing. So we need to import Plotly. For Plotly, we need all of these lines because it's an online service, but imagine this is just importing a library. And creating a plot, like a default plot in Plotly, is as easy as 5 lines of code. Here you can see it's 5 lines. We are not counting the libraries, but once you have your data, it's 1, 2, 3, 4, 5. So creating a plot, just default plot, it's really easy. For this plot, the only things that we're gonna modify are the titles and the axis labels. To create a plot in Plotly, you need 2 things, the layout and the trace. The layout gives Plotly the instructions on grids, on titles, axis names and ticks, to put a legend, to put labels, the colors and dimensions of the figure, and basically all general formatting of the figure. The trace contains which kind of plot you want, includes pairs of X, Y values that you want to plot. It's basically the data we want to visualize and how we want to visualize it, the little points in the bars. So we're going to start with a layout in which we modify the title, the axis labels. And for the trace, we're going to choose from the lists that we created before. This is a list called melting temperature and a list called Young's modulus. Remember, we created those back here, these 2 lists. So we can go back here. And from these 5 lines, you can get an interactive plot. Let me show you. So you can see that it's a pretty simple plot, but the cool features from Plotly is that this is already an interactive plot. The first things that you can, one of the main things for these interactive plots is that if you go to a point, if you hover over a point, you can get these kinds of labels. Here I'm representing X and Y values. So you can see without me telling explicitly this code, just with the defaults, I can already get hovering labels over the points. Another feature that it's really useful for these plots in Plotly is that imagine you have this graph. Imagine this was not a Jupyter Notebook, it was like a PDF. You can see that here there are a lot of points. And in a publication, you would see like a little square with a zoom in on those points if they were important. But in these interactive plots, you can actually zoom in the plot. Like I want to select this region, and you can get a bigger version of the region that you wanted to see from that graph. Remember, this was all 5 lines, but we can do better. We can create these plots and make it look nicer. So I'm gonna go through that here. So we can customize these plots by putting more lines of code. We're gonna color dynamically these markers. So you saw that I separated this into 3 categories based on one of the properties. So we're gonna do that, but for the colors of the markers. So in this function, if some element is in the first list, we're gonna color it this way and so on and so forth. And we're gonna create a list of those colors. So let's run that. This cell has no output right now, but you can print the list of colors if you uncomment this. Now going to a more custom plot. You can go through the layout, all of the modifications that we made, some of the dimensions and showing a legend, font sizes for the titles and grids. But the important thing is on the trace. On the trace, you can see that it's more complicated than the default. In the default, we had X, Y, and mode. X, Y, and mode. Here we're putting some size on the markers and some coloring that we created in the previous cell. We're also labeling each of the points with this sample. So if I run this, we can get a plot that looks like this. So you can see here how the plot was dynamically colored to match. Here's the atomic arrangement, the crystal structure. And this still has all the functionality from the first plot. So you can see now that it shows the XY pair, but it also shows what the element is. So you can see these Jupyter Notebooks have kind of a feel of like a textbook, but a textbook with live code that you can also modify. So it gets the best of both worlds. For material scientists, you could see a correlation here, but this is a dynamic correlation where you can see all of the points what they are. Now, once we have this custom plot, making another plot, it's as easy as just changing the trace from x, y being melting and a moduli, some of the moduli, to melting and this coefficient of thermal expansion. So you can just copy the cell before this and changing changing y, and you can get a similar plot with different properties. So this was an introduction to Plotly. Remember, the hover and the zoom in are a couple of the main characteristics of Plotly that make these interactive plots so useful. And now, this is the end of the demo on this notebook. I'm going to show you a resource in nanoHUB in which you can create your own Jupyter notebooks. So I'll need everyone to move from this notebook to this other notebook. So nanohub.org, tools, and then Jupyter. I'm going to wait a little bit so everyone can go to this other tool, and then we can launch it together. The link for the Jupyter Notebook tool is also in your handout. Okay, once you launch the tool, you're gonna find yourself in your home directory. It's gonna look similar to this, but probably empty. So we're gonna play with a couple of the buttons here in the home directory. With upload, it will pop up a window in which you can just, from your computer, upload anything and store it here in your home directory to work in your Jupyter notebooks. And from the menu new, you can create a new notebook. We've been using Python 3, so we're going to create one in Python 3. And if you're familiar with Unix environments and you want a terminal, you can also launch a terminal from here. Now, let's create a Jupyter notebook. So please click Python 3 in the menu new in your home directory. And this is how a notebook would look when it's empty. Some things that we can do right off the bat is change the name of your notebook. So just name it something. Test notebook 1. So some of the commands that you need for your Jupyter notebook is to create cells. So you can create cell. We did it before with this button. You can also insert a cell. So another cell. You can delete cells using the little scissors or in the menu edit. You can delete a cell. You can also undo your deleted cell in case you had something there and you want to get it back. So we talked before about two different kinds of cells, like right at the beginning. One of them was for text and one of them was for code. You can see which kind of cell you're looking at right now. So I'm in the first cell. You can look at what that is here. It would be either code or markdown. Markdown is the text cell. So if we go to a code cell, we can still run our Python scripts. So I'm going to print something. And it will work. So I'm not going to dwell into what you can do in Python. So if you want to run anything in Python and you need libraries, common libraries, they're already installed in nanoHUB. If they're not, you can just submit a ticket and you can get it installed. So I'm going to go through markdowns. Markdowns are the way we create these instructions or we explain what we're doing. So markdowns are coded by writing text, and then it's going to get parsed to HTML. But there are some things that we can do right out of the bat. You also have them in your handout. So we can start by putting sections. So if we do hash and then section, or hash hash and then subsection. Markdown cells are also, you can also run them the same way, Shift Enter. And you can see that we are creating these headings. You can also have another level. And you can see the formatting changing. You can create ordered lists with numbers. So I'm gonna create this list. and I can create another list and another list. I mean, another item in the list. And it's gonna show an ordered list, a numbered list. And I can also create unordered lists using hyphens or any kind of symbol. So you can create these bullets, and it's pretty easy to create. Some other things that you can do in Markdown are hyperlinks. So if I wanted to create this link, so link, and here I could put a website. I said nanoHUB. You can see that the color changes. And once we run this cell, this link will lead you to the website that you put in. This is in case you want to reference something, or you wanna some links for the user to go somewhere else. So you have the headings, you have the two lists, you have these links. Finally, we have HTML codes. So if you're familiar with HTML, you can go through this pretty easy. If you're not, I'm gonna show you some easy tags for formatting. So you can create B, which is a tag for bold text. And then BR, it's a tag for a break. So basically an enter. You can use I, it's italics. And you can see how this formatting is being translated to HTML. Another thing you can do, if you want to change a lot of things, you can do font and then color, red, size, 4. You also have to close that tag. And put some text in. Sample text. And you can see how the formatting changes using those tags. So these are some of the things that you can do in your Jupyter Notebooks. You can create these instructions and you can pair it with your live code to create these documents that are really powerful for visualization and to create these tools for the community to use and replicate your results in your data or just to work on your data. So with this was the demo for the Jupyter Notebooks, and I'm gonna go back to the presentation. So in this little workshop, we went through a lot of things. We introduced Jupyter Notebooks and some Python and started working with pandas and Plotly to organize and visualize. I showed you a tool in nanoHUB in which you can create your own Jupyter Notebooks. And with that, I'm gonna leave you with one of the slides from the beginning. So why are we doing this? Remember, data science and machine learning are playing an increasingly important role in science and engineering. So it is our responsibility to keep up with the times and start working in tools like this. And with that, I thank you all, and I'll head up to the Q&A session. Thank you. Any questions?
I have one to start. Juan Carlos, can you show us how to write equations using LaTeX on the Jupyter Notebook?
Yeah. So in Markdowns, you can also create LaTeX equations. They're in between dollar signs. X equals 5. And you can get translated to LaTeX.
So going forward, are we going to only use Jupyter Notebook as our IDE, or are we consider any other like Spice or using the PyCharm for IDE?
You mean for the next parts of the workshop?
Yeah.
It's all Jupyter Notebooks.
Okay, thank you.
Let me clarify that. So we're going to use Jupyter Notebooks, but the tools themselves that we run in Jupyter are available through other interfaces. So what you're going to learn, you can apply from different interfaces. We use Jupyter Notebooks because it's what we can run in nanoHUB run the same notebook at the same time and get the experience.
Juan Carlos, thank you for the tutorial. It was really informative. I have a question. Is it possible to save the information that you have in Jupyter to your desktop? Let's say that I want to then later use that information in MATLAB. Is it possible to export that information?
You can download the Jupyter Notebook. So if you go to here, File, and then Download As, you can download as a Jupyter Notebook, or you can download just as a Python script. So is that what you mean, like downloading the code?
So if you download the code, also the information that you're using, let's say for plotting, is going to be there, right?
Right.
Okay, so then we can use that information to do coding in other softwares, other programs.
Yeah, you can use the information that we get from here. If you save it to an output file, you can put it in any kind of software. If you're going to go to MATLAB, you can use Matplotlib, another Plotlib library. I mean,
Okay.
yeah, another Python library. And you can use that in these Jupyter Notebooks too.
Okay, thank you.
Let me clarify that you can the data, right? As you process the data and generate stuff, you can export the data, say Pandas data frame, and then use it in some other software.
Yeah, you can save from Pandas.
Can you use Jupyter Notebook without an internet connection?
To use it in nanoHUB, you'll need an internet connection, but I'm pretty sure you can use Jupyter from a dedicated environment in your computer too.
Yeah, you can download Anaconda and Anaconda. Muted. This is Professor Strachan. In your laptop, you can download Anaconda, and Anaconda would have Python and Jupyter, and you can run it right from there. It's a thing called Anaconda Navigator. But then you have to install this, and what Juan Carlos showed and what we will show in the is you need Jupyter, you need Plotly, you need a bunch of other libraries. You need to have firewalls open so you can access repositories that are out of nanoHUB. And so the solution, the advantage is all of these other infrastructure that we're going to use, all of the libraries, everything is pre-installed and ready to work. It's not just installing Jupyter. You have to install things like TensorFlow to do machine learning, like we're going to learn later on, or Keras. A bunch of other stuff, PyMatGen, libraries to interact with. So that's the advantage of running it in nanoHUB, but you can certainly run it offline in your own laptop or desktop.
Thank you for the tutorial. I have a question. Can we use the nanoHUB Jupyter to access local resources, for example, to connect to serial ports and instruments?
I am not familiar with applications that use like ports. You're thinking like something like using it to control like an Arduino or something?
Yes, maybe something like that, and collect data from connected devices to the computer.
So you can, if you can create your own file with your data, if it's not like a live application, you can upload that to your home directory and then use it in Jupyter Notebooks to analyze.
Yeah, so the server, these Jupyter Notebooks for iterative computing, or there's a server running in nanoHUB, and then it uses your browser to display. So in order to access the data from a port in your local computer, that needs to be transferred to nanoHUB, and that's what Juan Carlos was showing about uploading and downloading data. So I think if you want to control something or get it directly from your laptop or from a connected computer, put a ticket in nanoHUB. We can think about stuff, about ways of doing that, but that's not exact. That wouldn't be how the vanilla version wouldn't do it.
Thank you.
I have another question. How can I load data that is in my computer to the Jupyter notebook?
Okay, I can show you that. So if we go back to the home directory, you can click upload here, and it will pop up for something in your computer to one of the folders in your computer, and you can upload it. You can upload, for example, this. I'm going to tell you to upload it. This is a CSV, and once you have it here in your home directory, you can use it in your Jupyter Notebooks.
Thank you.
Yeah.
Any other questions for Juan Carlos or anyone in the team? So if you go back one slide quickly, Juan Carlos, the next set of lectures, hands-on lectures, will cover the rest of this picture. We're going to learn how to get data from repositories, learning about APIs. We're going to learn about training, developing models and training models. And so I invite all of you to keep coming back. And so let me ask again, are there any questions for Juan Carlos?
I got a question, a quick question. Is the information that we put in the Jupyter Notebooks public, or is it only private to us, the user?
Anything that you upload to your home directory is only accessible to you.
Thank you.
Hi, Juan Carlos. I have another question. What libraries do you recommend for image processing?
Image processing, as in using it for machine learning or data science?
Sure. Like, well, just for data science, like cross correlation or image enhancement, stuff like that.
So there's a library in Python called PIL. The Python imaging library has some filters for image processing, and it's compatible with PyTorch, I believe, if you want to use it in machine learning. So I would say PIL, Python imaging library, would be my first choice. But if you have another alternative, I would love to hear it.
No, I don't have it.
Yeah, so PIL. Yeah.
Thank you.
I have a question. So if I make like a plot in the Jupyter Notebook and I want to show it to someone who like doesn't use nanoHUB, will they be able to just open and view my notebook, or will they have to like log into nanoHUB?
That's a good question. So if you want to share it, you can share it, but they will be able to. So for the interactive plots, you can download a static plot. But if you wanted to share a Jupyter Notebook, I think you can.
Okay. Thank you.
You can share the notebook, and you can also, of course, make it into a PDF, right? And share the PDF document will obviously not be interactive.
You can from here, you can export to PDF.
For example, directly out of nanoHUB, out of Jupyter.
Okay. Thank you.
You can see it here, PDF or just PDF.
Any other questions for Juan Carlos? If not, I would suggest we all unmute and thank Juan Carlos for a great lecture and a very interesting tutorial.
Thank you.
Thank you.